Good morning, class. Today's lesson will focus on inverse trig differentiation. So inverse trig differentiation. All right, so what do we know about inverse trig functions? Okay, so let's take a look at the notation. Okay, so the way we learn this in Algebra 2 and Pre-Cal is we notated our inverse trig with kind of this little -1 here. In calculus, we're going to introduce the arc sign, arc cosine, arc tangent, etc. So these are equivalent. They're the same thing. So this does not mean 1 over sine of x, because 1 over sine of x gives us the cosecant of x. What this tells us is an inverse trig function is an angle measure. Okay? So an inverse trig function is an angle measure. So y equals arc sine of x if and only if sine of y is equal to x. So inverse trig gives us angle measures. Okay. So with that said, what do we remember about our inverse trig? What's our domain? What's our range? What does a graph look like? Okay, so let's take a look at arc sine. So you may recall that the graph of arc sine looks something like this. It has a domain of -1 to 1, and it has a range of -pi over 2 to pi over 2. Well, where does that come from? What's the story behind it? Oops. So again, where does that come from? What's the story behind it? If you recall, the graph of sine of x so here's pi, -pi, pi over 2, -pi over 2. Okay. So when we talk about arc sine or inverse sine, we're looking at where that expression will be a function. Now, in Algebra 2, you learn something about the horizontal line test. Okay, if you draw a horizontal line through a graph and it intersects the graph in more than one place, then the inverse does not exist. So the reason we limit the inverse sine from -pi over 2 to pi over 2 is because once you go outside of that, then you're not going to pass the horizontal line test. So we're restricting on purpose the domain of our inverse sine, our arc sine. because we want to maintain a function status for that. If we allowed our domain to expand outside of these borders, then this would no longer be a function. Okay? All right, so with that taken care of, how does this help us with differentiation? Okay, so let's go ahead and take a look at that. All right, so we'll go through all 6. All right, so here's our first one. Okay, so let's say, what is the derivative of arcsine of x? All right, so we're going to start off with y is equal to the arcsine of x. So arcsine, or inverse sine, and sine, they're inverse functions of each other. So if we take the sine of both sides here, so sine of y equals the sine of the arcsine of x, what ends up happening is we're going to get the sine of y is equal to x. Because as we learned yesterday, the composition of inverse functions, they undo each other and we're just left with this. Okay, so from this is where we're going to start with deriving the derivative of arcsine of x. Okay, so here we're going to start with a right triangle. We have an angle y. So here we know that sine of y is equal to x. Well, sine of y is x over 1. Sine is opposite over hypotenuse. So if this is angle y, then our opposite is here, and our hypotenuse is 1. So sine of y is x over 1, sine of y is x. So we can use the Pythagorean theorem to find our missing adjacent side here. So if we label this a, then we have 1 squared is equal x squared plus a squared. Right? Subtract x squared from both sides. 1 minus x squared is equal a squared. When we take the square root, you're going to get a is equal to the square root of 1 minus x squared. So this side here is the square root of 1 minus x squared. Okay, so we're going to need that. So here, if y is equal to the arcsine of x, then that means that sine of y is equal to x. Now let's take the derivative of both sides. The derivative of sine is cosine, so we're going to get cosine of y, but this is implicit differentiation. So cosine of y times dy dx is equal to 1. The derivative of x is 1. So dy dx is equal 1 divided by cosine of y. Now, we're still making reference to this triangle here. So the cosine of y is adjacent divided by hypotenuse. So dy dx is 1 divided by the square root of 1 minus x squared. Okay? So, the derivative of arcsine of x is equal to 1 over the square root of 1 minus x squared, and the derivative of arcsine of u is going to be u prime over the square root of 1 minus u squared. We can use the same pattern and style to solve or to derive the other 5 inverse trig functions. Right? So let's go ahead and take a look at arc cosine. Okay, so the derivative of arc cosine of x. So we're going to start off and we're going to say y is equal to arc cosine x. Okay, composition, take the cosine of both sides, then we get cosine of y is equal to x. So our triangle this time, because cosine is adjacent over hypotenuse, then if this is our angle y, then our adjacent side is x, our hypotenuse is 1. And using the Pythagorean theorem again, you're going to get your opposite side to y being 1 minus x squared. Now we take the derivative of both sides. The derivative of cosine is negative sine of y, dy dx, and that's equal to 1. So dy dx is equal to negative 1 over sine y. And based on our right triangle here, the sine of y is the square root of 1 minus x squared divided by 1. Opposite divided by hypotenuse. So dy dx would be negative 1 over square root of 1 minus x squared. Okay, so for arc cosine, the derivative of arc cosine of x is negative 1 over square root of 1 minus x squared, and the derivative of arc cosine of u is going to be negative 1 over the square root of 1 minus u squared times u prime. So we'll just do negative u prime over the square root of 1 minus u squared. Okay. All right. So here we're using the properties of inverses in order to derive these. All right. Let's go ahead and take a look at arctangent. Okay, the derivative of arctan of x. So if y is equal to the arctangent of x, then the tangent of y is equal to the tangent of the arctan of x. So that's just equal to x. So tangent of y is equal to x. So if y is arctan of x, then tangent of y is equal to x. Okay. So here's our angle y. Now tangent is opposite over adjacent. Opposite divided by adjacent. So that means that our opposite side is x and our adjacent side is 1. Okay, so if we call this a here, using our Pythagorean theorem, a squared is equal 1 squared plus x squared, square root, a is equal to the square root of 1 plus x squared. So this side here is the square root of 1 plus x squared. Again, using our Pythagorean theorem. Okay, so let's go ahead and take the derivative of both sides. The derivative of tangent is secant squared, so that's secant squared y dy dx, and that's equal to 1. The derivative of x is 1. So here we're going to get dy dx is equal to 1 over the secant of y, and we're going to square that. Okay. All right, so here's our triangle again. The cosine of y is adjacent over hypotenuse. Okay. So cosine y is 1 over the square root of 1 plus x squared. So that means the secant of y, secant is the reciprocal of cosine. 1 over the cosine is the secant, so the reciprocal. So secant of y will just be the square root of 1 plus x squared. So then dy dx, 1 over secant squared, that's going to be 1 over, secant is the square root of 1 plus x squared, but we're secant squared, so we're going to square that. All right, so the derivative of arctan of x is equal to 1 over 1 plus x squared. The derivative of arctan of u is going to be u prime over 1 plus u squared. Okay, so the derivative of arc cotangent is generated or derived in the same way. So I'll leave that to you as an exercise. But the answer there will be negative 1 over 1 plus x squared. And the derivative of arc cotangent of u will be negative u prime over 1 plus u squared. Okay, so let's go ahead and take a look at arc secant. The derivative of arc secant of x, okay, so we're going to start off and we're going to say y is equal to arc secant of x. Taking the secant of both sides, the composition of secant of both sides, we're going to get secant of y is equal to x. So the right triangle for secant of y is equal to x. So here's angle y. So cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. So that means our hypotenuse is x, and our adjacent side is 1. So if we call this a, using the Pythagorean theorem, x squared is equal 1 plus a squared. So x squared minus 1 is equal a squared. And a is the square root of x squared minus 1. Okay, so now let's go ahead and take our derivative of both sides. And so the derivative of secant of y is secant y times tangent y dy dx, and that's equal to 1. So dy dx is 1 divided by secant y times 1 divided by tangent y. which is cosine y times cotangent y. All right. So looking at our triangle, so dy dx is cosine y times cotangent y. So here's y. So the cosine is adjacent over hypotenuse. So it's going to be 1 over x. The cotangent, tangent is opposite over adjacent. So cotangent is adjacent over opposite. So that would be 1 over the square root of x squared minus 1. So dy dx is 1 over x times the square root of x squared minus 1. Now, because of the properties of secant that I'm not going to go into now, this x will need to be absolute value. So just make a note of that. So our derivative of secant x is 1 over absolute value of x, square root of x squared minus 1. And our derivative of secant of u is going to be u prime over absolute value of u, square root of u squared minus 1. Okay. Hopefully you've seen the pattern thus far with sine and cosine, how one is positive, one is negative, and for tangent and cotangent, one is positive, one is negative. So it's going to be the same thing with the secant and the cosecant. So let's just go ahead and put that one in your notes. The derivative of cosecant the derivative of cosecant of x will be negative 1 over absolute value of x, square root of x squared minus 1. And the derivative of cosecant of u will be negative u prime over absolute value of u, square root of u squared minus 1. Okay. Let's take a look at some examples. What is the derivative of arcsine of 2x? All right, so in this example, it's a chain rule. So we have a u. Our u is equal to 2x. So the derivative of arcsine of u is what? So if you have it memorized, the derivative of arcsine of u is u prime divided by 1 minus u squared. So if this is our u, u prime would be 2 divided by the square root of 1 minus u squared, or 2x squared. So that would give us 2 divided by the square root of 1 minus 4x squared. That would be our answer. Just keep in mind that tomorrow, when we do the integrals of inverse trig functions, we're going to start here and try to get back to here. Okay, let's take a look at another example. How about the derivative of arctan of 3x? So here, the derivative of arctan of 3x Well, the derivative of arctan is u prime. So if we have this memorized, then we label the 3x as u, then we know that the derivative of the arctangent of u is u prime divided by 1 plus u squared. So u prime, the derivative of 3x is 3 over 1 plus 3x squared, which is 3 over 1 plus 9x squared. And that would be our answer. Now, what if you don't memorize these? Can you still do these problems? And the answer is yes. Okay. So, looking at this problem, y is equal arctan of 3x. Tangent of y is equal to 3x. So here's our angle y. Tangent is opposite over adjacent. So there's 3x, there's 1. And now we would need to use the Pythagorean theorem to find the hypotenuse. So using our Pythagorean theorem, we call this a. Then we know that a squared is equal to 1 plus 3x squared. So that would give us 9x squared. Or a is the square root of 1 plus 9x squared. So if y is equal to the arctan of 3x, if tangent of y is equal to 3x, then taking the derivative of both sides, we get secant squared y dy dx is equal to 3. Dy dx is equal to 3 divided by secant squared y. And 1 over secant squared is cosine, so this would be 3 times cosine of y squared. Okay, so here, if this is y, cosine of y is adjacent divided by hypotenuse, so that would be 3 times 1 over the square root of 1 plus 9x squared, which is 3 over 1 plus 9x squared. Okay, so on the AP exam or on your Unit 5 test, how do you want to solve this problem? Do you want to have the formula memorized, or do you want to derive it? Either way, you're going to come up with the same answer. Okay, let's take a look at another example. A couple more. All right. How about the derivative of arcsine of the square root of x? Okay. So the square root of x is our u, and the derivative of arcsine of u is u prime divided by the square root of 1 minus u squared. So again, the derivative of arcsine of u is u prime divided by the square root of 1 minus u squared. Okay, so here, arcsine of square root of x. Well, we would need the derivative of the square root of x. So x to the 1/2. So that would be 1/2 x to the negative 1/2. Okay, so that's our u prime divided by the square root of 1 minus u squared, so it would be 1 minus the square root of x squared. Okay, so let's see. This would turn into 1 over 2, then the square root of x, because the x to the negative 1/2 is 1 over x to the 1/2, or 1 over square root of x. Square root of 1 minus square root of x squared is just x. Alright, now if we remember a property that says square root of a times square root of b is the same thing as square root of a times b, we can combine these two. So our final answer would be 1 over 2 square root of x minus x squared. So either one of these would be okay. Alright, let's take a look at one more example. The derivative of arcsecant of e to the 2x. So the derivative of arcsecant of u is u prime over the absolute value of u times the square root of u squared minus 1. So in this case, our u is e to the 2x. U prime is going to be 2e to the 2x. So the derivative of arcsecant of e to the 2x, we're going to plug it into this formula. It's going to be 2e to the 2x, that's our u prime, divided by absolute value of u. Now, e to the 2x is always positive, so I don't really need the absolute value. So e to the 2x times the square root of e to the 2x squared minus 1. So this 2x divided by that 2x is 1. So our final answer is going to be 2 divided by the square root e to 2x squared. Remember, when you have a power raised to a power, you multiply the exponents. 2x times 2 is 4x. So we're going to get e to the 4x and then minus 1. And that would be our answer. Okay, so that's it for today. So your homework is page 378, 41 through 60. Okay, and you are going to take a quiz today, so be prepared for that. All right, and I will see you tomorrow.